According to everything we know about physics, none of these objects should exist. The math doesn't allow it. The timeline doesn't permit it. There simply hasn't been enough time, since the Big Bang itself, for anything to grow this massive. And yet, we keep finding them. Phoenix A, 100 billion suns. Sitting at the heart of a galaxy cluster, 5.7 billion light years away. When we first measured it, we told ourselves it was an anomaly, a statistical outlier, a monster that had bent the rules just once. But Phoenix A is not alone. There is an entire hidden lineage of these objects. Ultramassive black holes that the universe should not have been able to build. Some are older, some are stranger. One of them may actually be larger than Phoenix A itself. Tonight, we are going to climb that lineage. 5 black holes, 5 impossibilities, 5 objects whose existence is forcing astrophysicists to question whether our model of the universe is missing something fundamental. We will count them down from the strangest to the one that breaks everything. My friends, leave a like, subscribe to the channel, and let's begin. Number 5. Holmberg 15A, the neighbor in the dark. Distance from Earth, 700 million light years. In cosmic terms, that is the house next door. Holmberg 15A sits at the center of a galaxy cluster called Abell 85, and for decades astronomers studied it the way you would study any large elliptical galaxy. They assumed its central black hole would be massive, maybe 1 or 2 billion solar masses. Impressive, but not unusual. In 2019, they finally measured it directly, 40 billion solar masses. More than 9,000 times the mass of the black hole at the center of our own Milky Way. Its event horizon is so wide that light itself would take nearly 4 full days to cross it. But what makes Holmberg 15A genuinely disturbing is not its size. It is the silence around it. The galaxy that contains this monster has a strange, hollow core, a region of empty space where stars should be, but are not. Astronomers believe Holmberg 15A scooped them out, ejecting entire generations of stars from the galactic center through gravitational slingshots, leaving behind a cavity larger than several Milky Ways, stacked end to end. It didn't just grow at the center of its galaxy, it hollowed it out. And it is the closest object of its scale that we have ever found. Number 4. IC 1101 Central Black Hole. The throne at the end of a world. If Holmberg 15A is the neighbor, IC 1101 is the cathedral. IC 1101 is one of the largest known galaxies in the observable universe. A colossal elliptical structure spanning roughly 6 million light years. If the Milky Way were a coin on your desk, IC 1101 would be the entire desk. At its center sits a black hole estimated between 40 and 100 billion solar masses. The uncertainty range alone is wider than the entire population of stars in some smaller galaxies. But here is where IC 1101's central monster becomes genuinely unsettling. This black hole is dead. It has almost certainly eaten everything within reach. The accretion disk has gone cold. The jets have shut down. It is not a sleeping giant. It is a giant that has finished its meal and gone quiet. We are looking at a black hole that has consumed an entire generation of stars and gas, and now sits in stillness at the heart of a galaxy that is itself slowly dimming. The galaxy and its black hole are aging together in synchronized silence. If you want to know what the end of a galaxy looks like, look at IC 1101. It is what is waiting for all of them. If that thought made you uncomfortable, that's the point. Subscribe to Beyond Orbit. We go places the textbooks won't. Number 3. SDSSJ 140822167 plus 025733.2. The Forbidden One. The name is a coordinate, a string of numbers astronomers use because no human name felt appropriate. This object sits in a quasar, one of the brightest, most violent objects in the universe, roughly 4.2 billion light-years from Earth. Quasars are powered by supermassive black holes feeding at extreme rates, and astronomers were used to finding monsters at their centers. But when they measured this one, they refused to publish the result for months. Approximately 196 billion solar masses. Nearly twice the mass of Phoenix A, the number was so far outside what standard models could explain that several teams independently rechecked the calculations, suspecting an error. The measurement held. The black hole at the center of SDSS J140821 is, by some estimates, the most massive single object ever measured in the observable universe. But here is the deeper problem. We are seeing this quasar as it existed roughly 4 billion years ago. The light that reaches our telescopes left it before our own sun had finished forming, which means this object was already that massive when the universe was significantly younger than it is today. The math is brutal. Even if this black hole had been feeding at its absolute physical maximum for every second since the Big Bang, it still should not have reached 196 billion solar masses. Something happened. Some process we don't understand. Some shortcut the early universe took that allowed mass to collapse in a way our equations cannot reproduce. SDSS J140821 is not just a black hole. It is a question we have not figured out how to ask. Number 2, TON 618, the lantern in the void. For nearly a decade, this was the king. TON 618 is a quasar so distant that the light reaching our telescopes today began its journey when the universe was less than 4 billion years old, 18.2 billion light-years away. So far that the space between us and it has expanded by an almost incomprehensible amount during the photon's voyage. And at the center of that quasar burns a black hole of 66 billion solar masses. But TON 618's identity is not really its mass, it is its luminosity. TON 618 is one of the most luminous objects ever observed. Its accretion disk pours out energy at a rate equivalent to 140 trillion suns. If you placed TON 618 at the same distance as our nearest stellar neighbor, it would outshine the entire night sky. It would, in fact, outshine the day sky. It would be brighter than our own sun seen from Earth. This is what a black hole looks like when it is feeding without restraint. The radiation pouring from TON 618 has been escaping outward for over 10 billion years. By the time this light entered our telescopes, the photons themselves were tired, stretched by the expansion of the universe into a deep ancient red. We are not seeing the present of TON 618. We are seeing its youth. What it looks like now, we cannot know. Number 1, Phoenix A, the one that broke the scale. We have already talked about Phoenix A in detail. 100 billion solar masses, 5.7 billion light-years away. An event horizon roughly 590 billion kilometers across, wide enough to contain 100 complete solar systems lined end to end. But after walking through the others, Phoenix A takes on a different meaning. It is not the biggest. SDSS J140821 may be twice its size. It is not the brightest. TON 618 outshines it across cosmic time. It is not the closest. Holmberg 15A is far nearer. It is not the most dramatic. IC 1101's black hole rests at the heart of a dying cosmic empire. Phoenix A is something else. Phoenix A is the one that is still building. While the other ultramassive black holes have either gone quiet or have been frozen for us in ancient light, Phoenix A is actively, visibly, in the present cosmic moment, generating new stars at a rate of approximately 740 per year. Its jets are not finished. Its hunger is not satisfied. Its galaxy is not aging. It is being born again around it because of it. Phoenix A is the one we caught alive. If the others are tombstones, Phoenix A is the heart still beating. And that is what makes it the most terrifying of all five. Because if Phoenix A is still growing, then the upper limit of what a black hole can become has not been written yet. The universe is still showing us the answer. We are not at the end of this discovery. We are at the beginning. The question that will outlast us. 5 black holes. 5 impossibilities. 5 objects that should not, by the rules we wrote, exist in the configurations we have found them in. And these are only the ones we have measured. The observable universe contains roughly 2 trillion galaxies. We have directly weighed the central black holes of fewer than 200 of them. The ones we have cataloged: Phoenix A Tune 618, SDSS J40821, IC 1101's Monster, Holmberg 15A, represent a vanishingly small sample of what is actually out there. The next decade of astronomy may reveal black holes that make Phoenix A look small. Objects so massive that the very framework of how we describe gravity may need to be rewritten. We thought we understood the rules. We were wrong. Tell me in the comments, which of these 5 disturbed you the most? The one that hollowed out its own galaxy? The one that died in silence? The one we are forbidden to fully explain? I read every response. In the next video, we go somewhere even darker. Until then, keep looking up.